So again, we're solving for x. We want to find an x that will fit in here and make this equation work, where the left side is equal to the right side. Now, up until now, the ones that we have solved, we were using the strategy of isolating the x, which works really nicely for linear equations, meaning there's no squares on the x's that don't disappear. So in this case, we have that situation. We have an x squared and an x. The problem with isolating, it's not going to work here because you can't isolate the x squared because the x is there. You move the x over here, then there's x's on both sides. There's no way to isolate it because you can't put those two together. So what to do? So it's a totally different strategy when you are solving a quadratic equation, when you have a squared. So these two strategies that we're going to learn now are for quadratic equations. And those equations have an x squared. All right? So the first step you're going to do when you're solving for x with a quadratic equation is, one, you're going to make it equal 0. So instead of isolating, you're doing the opposite. You're moving everything over onto the same sides. I mean, the 10 is going to come over, and you're going to make it so there's nothing on the other side so that it's equal to 0. In a minute, you're going to see why that is really important. Now, before I continue, because you probably already know what to do, I'm going to put my pencil down here, and I'm going to think. It's kind of almost unrelated, but I want you to think about two numbers that would multiply together, and the answer would be 0. So if you think for a minute, two numbers that multiply together, and the answer is 0. Well, I could think of like 0 and 8. If I multiply those two numbers together, I get 0. Or negative 13 times 0, that would also be 0. But can you think of two numbers that multiply together to give you 0 where neither of the numbers are 0? And if you think about that for a little while, you'll discover that there are no numbers that multiply together to give you 0 unless one of them is 0. Could be both, but at least one has to be 0. That little fact, the fact that two numbers multiply together to give you 0, one has to be 0, at least one has to be 0, is what all of this is based on. So it's really important that you understand that. So the first step was make it equal 0. The second step we're going to have here is we're going to factor. And in a minute you're going to see why we're going to factor. But we know how to factor. We're good at it now. We have 3 terms to factor. That's a trinomial. It's a simple trinomial because there's a 1 in front, so I'm going to use the simple man method. Multiply to negative 10, add to negative 3. Oh, it's multiplying to a negative, it's negative and a positive. Blah, blah, blah. Oh, negative 5 and a positive 2. And because it's a simple one, I simply have to put down my 2 brackets. And that's minus 5, and that's plus 2. Okay, so now I have factored it, which means it's the same exact expression, it just looks different now. And how it looks differently is now we have, instead of a series of things added and subtracted, we have 2 terms multiplied together, right? That's multiplied, equal to 0. And the one thing we know is if two numbers, now we don't know what the x is, so we don't know what these numbers are, but we know that if we multiply them together, the answer has to be 0. And if two numbers are multiplied together and the answer is 0, either that one equals 0, so either this one is 0, or that one's 0. There's no other choice. Now, what you have when you've got that far is like, oh, well, then these are just miniature little linear equations. I can isolate this. That means x is equal to 5, or x is equal to negative 2. Both of those will solve my equation. If you put them back in here, 25 minus 15 is 10. Okay, that worked. Negative 2 squared is positive 4, plus 6 is 10 as well. So both of those are solutions. But it all hinges on the fact that when you have it factored, those two terms are multiplied and the answer is 0. That's why you have to do the first step is make it 0. So the first step is make it 0. Second step is factor it, so you have two numbers multiplied together. Third step, make both factors equal 0, because we know one or the other of them have to be 0. And then solve. The mini equations, I call them. Okay, so that's called solving by factoring quadratic equations. So let's try a little harder one. Okay, again, I notice, well, you could try isolating, but you know the squares are not disappearing, and you have this other x. So we're going to go 2x, remove the x squared. You know what? I'm going to change my mind there. I'm not going to change, I'm going to move it all over to the other side. And the reason for that is if I move the 4 over here, I'm going to get a negative, and then I got to factor out the -1. I don't want to do that. So I'm going to put the 0 on this. It doesn't matter which side of the equal sign you put your 0 on. And then I'm going to move everything to the other side. So we have 4x squared, move that 2x over there, it'll be minus 2x squared, minus 5x. I always put it in descending powers of x. That becomes a plus 3. Okay, so we have 2x squared. See how that's not a negative? That's much better for us. Saves time. All right, so same as before, I now have 0 equal to a quadratic equation. We're going to have a squared, an x, and a number. So my next step is to factor it. So I've done the first thing, I've made it 0, factor it. Now I'm going to use the man method again. However, it's going to be a complex man method, right? Because there's a 2 there, and there's no common factors. So multiplying to 2 times 3, which is a positive 6, adding to a negative 5. So it'll be 2 negatives or 2 positives, and because that's a negative, it's going to be 2 negatives. It could be, now we have to be careful with these 5 and 6 ones. Sometimes they're tricky. 1 and 6, both negative, do not add to negative 5, but negative 2, negative 3 do. So there we go. And now we have to remember to divide both by 2 and reduce the fractions. Negative 1 over 1 and negative 3 over 2. Okay, maybe you can see that a bit better if I move it up. There. So these are, I think, now remember I go from bottom to top, filling in the bracket, 1x minus 1, so x minus 1, and then 2x minus 3. And then now I have it factored. This times this equals 0. That means either this one equals 0. Now after a while, you get x minus 1 equals 0. You know the answer is going to be x equals 1. But ones like this one, 2x minus 3 equals 0, or a little less obvious. So that's why it's a good idea to understand what you're doing here. So we're factoring, and then we're making each factor equal to 0, and then we're solving these little mini equations, 3 over 2. So there are 2 solutions. X could be 1, or x could be 3 over 2.